pretty nervous about I'm going to talk in English. It's such a fantastic place. Anyway, I'm going to talk the representation of one of edgy Japanese web developers. So let's get started. Hi, I'm Yutaka. I'm doing engineer at a company called Pixel. I'm working on a 3D character platform that's called Vroid Hub. I'm also a demo machiner, doing WebGL stuff as my hobby. So today I'm going to talk about implementation of 3D character viewer on web. Firstly, I talk about VRM, a format for 3D avatar. Secondly, I'm going to talk about its implementation on web. Lastly, some issues we encountered during our development. So first, let me talk about our web service called Vroid Hub. In context, nowadays it becomes really easier to make your own 3D characters. Then, Vroid Hub aims to be a hub of 3D characters. So on the web end, we must present the 3D character on web browser, utilize its full potential. So we're using 3D character format called VRM. VRM is pretty good at express 3D characters. Actually, VRM is an extension of GLTF. GLTF is format for 3D models. It's proposed by Kronos Group. So VRM has so many features to deal with humanoid avatars. For example, you can refer characters specific bone with ease, like hips or legs or wherever. Or you can see its metafields that describe its license or conditions. For example, can you use this avatar as your own avatar or not? Or etc. So, yeah. Sorry, the slide isn't displayed on my end. Yeah, however, most of these specs are meant to be used by modern game engines like Unity or Unreal Engine. So we had to adopt the spec into how we treat the 3D stuff on the web. Also, Pixel is one of the committees of an organization called VRM Consortium. So we are discussing the specification of the format VRM. Well, so let's go on to talk about implementation. We implemented VRM importer as a module of 3JS. 3JS already has GLTF implementation, so we only had to implement VRM specific features. We released our implementation on GitHub very last week. So if you are interested to the VRM, please check this repository. So I'm going to talk especially about implementation of materials. In VRM, we can use a material called mtoon. Mtoon is basically a toon material, but it has so many features. Here's a comparison of simple material and mtoon. As you can see, you can notice that mtoon is way more expressive. So in 3D world, we describe how materials looks like using a program called shader. Here is a simple example of shader program. It just says simply output the input color. Or this another example says do a texture mapping. So since shaders are described as a program, it lacks portability. we need well-described material specification to implement a material for various platform or context. In GLTF, an interface called PBR material is used, and it's very common since it's based on academic researches. PBR stands for physically based rendering. So it's basically very good at express photorealistic materials. However, the specification of M2 is completely different from PBR materials since it's Lux material. And sadly, we don't have any documentation for implement M2. They're just actual implementation of Unity. So we have to convert actual Unity implementation into 3JS. So as I said before, M2 has so many features. Yeah, and then we had to write pretty long shell code. It was really painful time. Yeah, this is just my opinion, but I think it should be notable. In these days, most of 3D CG software have node-based material editor. 3JS also has node material. That is still experimental stage though. So if we can describe the specification of our M2 material as a portable node notation, that will be great. Lastly, I'm going to talk about some issues we encountered during the development of World Hub, our service. World Hub is meant to be visited from both PC and mobile devices. So we have to make our experience tolerable even on mobile devices. But as you can see, outline looks pretty greasy without anti-alias. Anti-alias is a technology to perceptually remove the aliases. We cannot use much sample anti-alias on WebGL. Can use in WebGL 2 though, but WebGL very few devices supports the WebGL 2. So we are rendering our entire thing on double resolution plus doing post-processing anti-alias too. It's pretty expensive on mobile devices. So we wanted to implement quality control on our render. We want to render things in higher quality on high-end devices, but not for low-end ones. And we are doing web application. Then we don't want to let user tweak setting window like thing. We wanted to adaptive quality control. But inspecting one's processing power on the end is pretty hard. There's one option that's the actual frame per second, but FPS can be subject of various conditions that it's purely not device power. Plus, there are two kinds of 16 FPS in this world. Our render, one renders our stuff with ease, but the other is using its maximum power. So we wanted to measure the processing time, actual processing time, but we cannot see the GPU time. However, there's a WebGL extension that can measure the GPU time, but it's still well not supported, especially on mobile devices. So we are currently falling into seeing FPS on the end at a very low threshold. We also are encountering security issues. It's relatively harder than native application to protect users' creation on web. We have to protect users' creation at all costs. In World Hub, there are users who sell those textures on their shop, so we even want to protect only textures. In context, we are currently using binary format, plus it's encrypted. So it's hard to crack the model data. And more context, we have to take these steps to show 3D models with texture. First, fetch a binary and get the image chunks, then send the image to GPU. As I said, we don't want the user's texture being yoinked, but it gets exposed when you just open the browser dev tools if you use HTML image element. So we are preventing this by decoding the texture by ourselves. By the way, Web Codecs API has been proposed several months ago. It would be nice to decode audio and video. And also, I think it would be nice if we can have the equivalent of this API for the images. Okay, here's a summary. And that's the end of my talk. Thank you.